Okay. Hello. My name is Muhammad Rafi Hanif. Here, I would like to present about the journal with the title of Fault in Diagnosis of Power Transformer using Random Forest-Based Combined Classifier. This journal is arranged by Rahman Azis Prasojo, Rahmat Sutjipto, Muhammad Rafi Hanif, Chalvyn Rahmat Dermawan, and Indra Kurniawan. Now we are going to the next slide. Background of our journal. Transformer is a vital and expensive equipment in a power system. So we need to carry a good maintenance to prevent the transformer fault. The preventive maintenance, there is a lot of preventive maintenance that used to prevent the transformer into the transformer fault. One of the preventive maintenance is DCA test or dissolved gas analysis test. Dissolved gas analysis test, we use oil transformer to know about the fault on the transformer itself. The oil transformer will process with the DCA tester equipment, and then it will show the gas concentration that dissolve on the oil. And then we process it refer to the IEEE C57104 2019, and then we combine it into the random forest classifier to code easier and high accuracy of the result, and then the result will give us the maintenance recommendation for the transformer itself. IEEE C57104 2019 is a standard or guideline of DCR test on oil immersed transformer. And this one is used to determine abnormality of transformer condition and to measure the fault severity of the transformer. And then the last is to determine maintenance recommendation action according to the fault diagnosis. And this is the flow diagram of IEEE itself. So the first is obtain transformer DKA data by laboratory test, and then determine the abnormality of the transformer condition, and determine fault severity of transformer condition, and we're going to the last step is maintenance recommendation. So for the fault identification method that we use in this journal is the fault triangle method. So there is a three the fault triangle method, such as the fault triangle method 1, the fault triangle method 4, and the fault triangle method 5. So for the first step, we have to use the default triangle method 1 to identify the fault that occur on the transformer. And we have to calculate the percentage of methane gas. We have to calculate the percentage of ethylene gas, and we have to percentage calculate the percentage of acetylene gas. And then if the DM1 give us result as PD T1 or T2, it will goes to the further fault identification method using the fault trigger method 4. And then if the DM1 gives us the result as T2 or T3, and we have to use the fault triangle 5 uh, as a further fault identification method. So for in the right side, that's the name of the fault that occur on the transformer. Like PD, a partial discharge, T1 is low thermal fault, T2 medium thermal fault, T3 high thermal fault, T1 low energy electrical discharge, T2 high energy electrical discharge, T3 is indeterminate fault, S is stray gassing, C is paper carbonization, O in overheating, and NB is notified. So in this journal, we also use a random forest machine learning, yeah, and there is a scheme that uh, we use random forest on this research is the input. We use the gas concentration, yeah, the gas concentration will process with the default triangle method with random forest based classifier, and then the output will give the fault type on the transformer itself. The scheme for random forest processing start with the intersection of five hydrocarbon gas concentration, which are the process with the random forest classifier to diagnose the fault based on the fault triangle method. To achieve high precision in the fault determining using the random forest network, selecting the right tuning parameter is mandatory. And you can look at the right top side. So we provide the variation of tuning parameter and observe value for random forest model. So the parameter is number of the trees, sample leaf size, and criterion. And then the data sample is used to train the accuracy of the output result from random forest implementation. And then we also have the data sample with all fault type and with process with default triangle 1, 3, and 5. And you can look at the table on the right and below side. And then this is the flow chart of our research start and then goes to literature study and then to obtain data, DKA data, and the next is compute data and rate value, and the next is if all causes below the table 1 and all delta below the table 2 and all rates below the table 2. If it is yes, the transformer we will get the condition as TKA status 1 and then directly going to the maintenance recommendation and finish. And if it is no, we are going to the next steps. If any case is lead to table 1 or any case lead to table 2, if it is yes, the transformer will go the condition as TKS status 3. And if it is no, the transformer will go the condition as TKS status 2. Transformer that got the condition as TKS status 2 or status 3, both of them we need to go to the more to the next step is perform TTM fault identification, and then it will give us a maintenance recommendation for the transformer. And then the random forest that we use in this research, we need to train the random forest model for TTM number 1, 4, and 5, and then vary the tuning parameter on TTM, and then select the best performing model. So the obtained TKA data that we have, yeah, TKA data that we have, it can be processed directly with the uh, random forest that already choose the performing model to perform the DTM fault identification. And then it goes to maintenance recommendation and finish. So the random forest implementation result for the default triangle method 1, we using entropy as criterion with the leaf sample is 10 and total of 500. Trees achieve an accuracy level of 0.96. For the default triangle method 3, using entropy as a criterion type with the leaf sample size of 10 and a total of 50 trees achieve an accuracy level of 0.99. And for the last one, use default triangle method 5 using entropy as criterion type with a leaf sample size of 10 and the total of 100 traits achieve an accuracy level of 0.97. For the implementation, we use six case study of different transformer, and then those are transformer with uh, the the parameter by itself, including the age of the transformer, the gas concentration of the each transformer, and then this data will process with the random forest that we already explained before. And then the result gives us as in the presentation. You can see it for the transformer number one, the TKI condition is status 2, and the fault identification is low thermal fault with not defined. And for the transformer number 2, got status 3 with the low thermal fault and overheating. For the transformer number 3 and 4, got the condition as status 1, so we don't need to calculate the fault identification. And for the transformer number 5, got status 2 condition with the low thermal fault and stray casing. And for the last transformer is transformer number 6, got status number 3 with the low thermal fault and overheating. So we are going to the conclusion, okay? So the conclusion is the outcome demonstrate that the optimal leaf size and criterion for all default triangle methods are typically with 10, 10 size, yeah, 10 with an entropy criterion. Default triangle 1 with 500 trees achieve 96 percent accuracy. Default triangle 4 with 50 trees achieve 99% accuracy, while the default triangle 5 with 100 trace achieve 97% accuracy. Interpretation using IEEE was performed to determine the condition of the transformer. The analysis revealed that transformer 1256 exhibited abnormal condition, which are categorized as DJI status 2 and DJI status 3. Implementing the default triangle with a random forest classifier result in the identification of low thermal fault T1 in a transformer 1, transformer 5 show as stray casing fault diagnosis, and transformer 2 and 6 exhibited overheating below 250 degrees Celsius. The integration of the fault triangle method with a random forest classifier has demonstrated the potential to increase diagnosis accuracy, particularly in a complex fault scenarios. And this enhanced accuracy could lead to more informed maintenance strategies and ultimately improving power grid reliability. For the future research is expected to be accomplished using a random forest model with a multi-method TKA model, which combining result of the default triangle, default pentagon, Rocker ratio method, and IC ratio method. So that the last presentation that I can give to you. Thank you for the attention and goodbye. Thank you.